We have all been there. You know, that system that's just too slow. That spinning wheel, the lagging API, it's super frustrating for users and, let's be honest, a nightmare for developers. But what if I told you that most performance problems can actually be solved by mastering just 3 fundamental techniques? Today, we're going to break down that exact toolkit to make your systems faster for good.
So I want you to think for a second. Where is your biggest bottleneck right now? Is it a really slow database query? A super heavy API endpoint? Get that specific problem in your head, because we're about to find the right tool to fix it.
Because, no matter what the specific cause is, the solution likely involves one of 3 really powerful fundamental techniques. We're going to walk through a super clear framework to identify and tackle these performance issues so you can solve them permanently. Let's get into it.
So here's our game plan. First, we'll introduce the 3 main levers you can pull. Then, we'll do a deep dive into caching, which is a big one. After that, we'll talk about batching and concurrency. And we'll wrap it all up with the most important part, how to actually measure your success and put all of this into practice.
All right, this right here is the core of our framework. When you need to optimize a system, you basically have 3 main levers you can pull, and really understanding these is the key to unlocking some serious speed.
And here they are: caching, batching, and concurrency. I want you to think of these as your performance toolkit. Now, it sounds like a bold claim, but pretty much every optimization strategy you'll ever see is just a variation or some combination of these 3 big ideas. So let's quickly define what each one means.
First up, caching. The principle here is so simple. Just avoid work you've already done. You can imagine a busy bartender, right? Instead of slicing a new lemon for every single drink, they slice a whole bunch at the start of their shift. That's caching in a nutshell. You do an expensive thing once, and you save the result for next time.
Next is batching. This is all about grouping similar tasks together to cut down on overhead. Think about it like loading a dishwasher. You wouldn't run a full cycle for one dirty plate, would you? Of course not. You wait until it's full. Batching is that same logic, but for code. You process 100 database writes in one efficient go, not one at a time. And finally, we have concurrency. Think of this as your system's ability to juggle. Instead of handling requests one by one in this slow single-file line, a concurrent system can work on lots of requests at the same time. This dramatically increases its throughput, which is just the total amount of work it can get done.
So let's dive a little deeper into caching, because honestly, it's often the first and most impactful lever you can pull. Anytime you find a slow operation, the very first question you should ask yourself is, can I cache this?
So what makes for a good caching candidate? Well, things that don't change very often. Stable tool results are just perfect. If a function always gives you the same output for the same input, cache it. The contents of static files, embeddings for search, and especially responses from slow external APIs, these are all prime targets.
Now, when you implement a cache, you have a pretty key decision to make. For pure simplicity, an in-memory cache is blazing fast. But the catch is, it only exists within a single server. As soon as you scale up to multiple servers, they can't share that cache. And that's when we need a distributed cache, something like Redis. It adds a little more complexity, sure, but it allows all your servers to share the same cache data, which is absolutely crucial for consistency.
But caching comes with one huge catch: stale data. What happens when the original information changes? You absolutely must have a strategy to invalidate or, remove the old entry from your cache. Forgetting this step is one of the most common sources of bugs, and it leads to users seeing outdated and really inconsistent information.
Okay, let's move on to our next 2 levers, batching and concurrency. These are your go-to tools when you're not just dealing with a single slow request, but a really high volume of requests that all need to be processed efficiently.
So let's take a classic example. Imagine your application needs to write 100 new records to a database. The simple, kind of naive approach is to just send 100 separate insert commands. The problem is, each one of those has its own network and transaction overhead, and that adds up incredibly quickly.
Batching transforms that slow, winding road into a direct highway. Instead of 100 separate, costly operations, you can group them all into a single, bulk transaction. The performance gain here isn't small. It can often be orders of magnitude faster, and it dramatically reduces the load on your database.
Now for concurrency. For any tasks that spend a lot of time just waiting, like for a network call to finish, you can use patterns like async await. This frees up your server to handle other requests instead of just sitting there idle.
For heavy CPU-intensive work, a thread pool lets you run tasks in parallel without overwhelming the whole system. And for databases, you should always use a connection pool. This reuses existing connections instead of paying the expensive cost of creating a new one for every single query.
So we've got our toolkit, but how do we know if our changes are actually working? This brings us to the most critical part, measurement. You can't optimize what you can't measure, so you absolutely, positively need to start with good instrumentation.
These are the vital signs of your application's health. You've got to pay close attention to P95 latency, not just the average, because that tells you the experience of your unhappiest users. Throughput measures your total capacity, and the cache hit rate tells you if your caching is actually doing its job. And finally, a growing queue depth is a critical early warning that your system is getting overloaded.
Your cache hit rate is a perfect metric for a dashboard. A high rate, like the 75% we see here, is great. It confirms your cache is doing its job and absorbing load. But if you see this number start to drop, that's a clear signal to investigate. It could mean your user traffic patterns have changed, or maybe your cache invalidation rules are just too aggressive.
And this right here is why looking only at average latency is so misleading. Sure, the median user at P50 has a great experience, only 120 milliseconds. But at the tail end, your P99 users are waiting over a second. To build a system that feels fast for everyone, you have to focus on optimizing for these higher percentiles, like P95 and P99.
So let's put it all together in an actionable checklist. First, start by profiling your code to find the actual slow spots. Don't guess. Then, apply our levers, use caching for expensive repeatable operations, and implement batching and concurrency where it makes sense. Finally, monitor your key metrics and set up alerts so you know immediately if performance ever starts to degrade.
All right, we've covered the framework, the techniques, and the metrics, so now it's back to you. Think about that bottleneck you identified right at the start. Which of these levers, caching, batching, or concurrency, are you going to pull first?